3D printers turn computer models into real physical things. They do this by building up an object in a great many very thin layers. Some technologies achieve this by extruding a molten material, such as a standard thermoplastic from a printhead nozzle. Other technologies lay down successive layers of powder that are selectively fused solid with a laser beam or other heat source, or else bonded with a spray-on adhesive. For many years, 3D printing has been used in rapid prototyping and to help produce mould masters. But more recently, pioneers such as Freedom of Creation and Make Eyewear have begun to use 3D printers to digitally manufacture final products or parts thereof. This means that it's already possible to purchase spectacles, furniture and many other items that have been 3D printed, and this trend is set to continue. Today, 3D printers can build items in a wide variety of materials, including plastics, metals, glass, concrete and chocolate. As the technology develops, this will allow an increasing number of parts and products to be stored digitally online. Items will then be able to be delivered digitally across the internet, so reducing physical transportation costs and permitting more local manufacturing. Because it's an additive process, 3D printing will also reduce materials wastage, as well as permitting high levels of product customization. To help demonstrate the possible impact of 3D printing, let's consider how people buy shoes. Today, when somebody wants some new footwear, they usually go to a store. Gathered together in this location are a predetermined number of styles and sizes from which they can choose. All of these shoes have previously been manufactured in distant factories in the hope that somebody one day may want to buy them. Now, let's consider what may happen in the future. Rather than travelling to a store, a customer may go online, select a design, colour, material and size, and then print out their shoes on a personal 3D printer in their own home. Creative consumers may even customise their shoe design using an app created by the manufacturer, or may even come up with a new shoe style all by themselves. Of course, many people may not want or be able to afford a personal 3D printer. Nevertheless, they could still create or customise their own shoes on a computer and then use an online printing service to dispatch them to their own home. Alternatively, they may visit a local 3D printing bureau to get their shoes printed out. Or perhaps they may still purchase their shoes from a specialist footwear store, but now one that is able to offer a far wider range of digital designs that are printed out on demand. In time, it may even be possible to return an old pair of shoes so that the material they are made from can be recycled and reprinted into a new design.
Today, I'm introducing you to some of the models that I've recently produced on the ObjectConnex 500 multi-material 3D printer. So come have a look. Here we have a series of 6 wrenches that I printed. All of these wrenches were printed at the same time on the same build tray. You can actually see inside all 6 of the wrenches being produced. They're now being printed. All of them are printed on the same tray at the same time. And as you can see, the print head moves backwards and forwards. It jets a photopolymer resin onto the build tray in 16 micron layers. After each layer is laid down in liquid form, as you can see, there's a UV light that follows the print head and it cures the material immediately after it's laid down. In other words, it hardens the material. Once the material is hard, you have the next layer that's placed on top. Now this process goes on until the final prototypes can be taken out of the machine. Over here on the computer screen, you can actually see the CAD design. This is your initial CAD design. This is how it looks on the screen. And as you can see, you have your build tray and you can arrange how you're going to print your various spanners and how you're going to lay them out. So in this case I'm printing 6 at once. What's also great about the Connex is that I can print these different wrenches in a variety of different materials. In this case I printed them in ABS-like material, and we can also print them in a variety of Vero and Tango materials, which are flexible and rigid materials which have different shades and textures. Once these come out of the tray, we then take it to the washroom. As you can see, there is a material on these, a support material. A support material is required when there's complex geometry such as these moving parts. There's always going to be a gap in between, and this gap needs to be supported. So we have a support material that's washed away very easily with a water jet. And then you have your finished part.
Now, about 3 weeks ago, we were contacted by some very clever people here at Filton who said they had a new machine that could make virtually anything out of powder. And to prove it, they said they'd make us a bicycle. Dave Harvey takes up the story.
It may look like the surface of the moon.
Actually, the guys here can make pretty much anything out of this.
It's the raw material for a completely new way of manufacturing. Well, it looks as if they've cracked it.
So you must be pleased. Are you pleased?
Yeah, we're pretty happy with the way it looks, definitely. It's a prototype, but you know, it's a great first step, definitely. We're really happy with what we've achieved.
Boeing Phantom Works system engineer Jake Irwin works in another dimension. Using a breakthrough 3D printer, Irwin and the Boeing Immersive Development Team can create three-dimensional models and objects the way most people make paper copies at the office. The printer is smart.
It takes the solid model and it divides it, and then it prints each one of those layers on a layer of powder.
Capturing Irwin's two-dimensional image of this Boeing concept jet fighter and translating the data into a solid object that takes shape before his eyes, layer after layer.
We use them for rapid prototyping. You have a concept and you want to visualize the prototype. My name is Dan Seal and I'm the program manager for the Boeing Immersive Development Environment. We think this is a key to unlocking the innovation of our employees. You can go from your computer model to a physical prototype you can hold in your hand within an hour or two.
Other 3D prototypes like this bracket, which illustrates a stress point in vibrant colors, and this bearing that actually moves, were also made on the printer.
Here's a nearly finished model ready to go.
His concept model almost finished. Irwin carefully brushes off the excess powder from the model, then applies a clear coat of solution that brings out the colors.
Again, there's no fumes, there's no hazards associated with using this because it's all contained in a hood.
A 3D model made by a printer, bringing Boeing into a new dimension of innovation.
Last month, London hosted an intimate event that showcased what was widely reported as a new way to produce things, by printing them. On show, a variety of objects from toys to intricately designed fashion items, and a live band playing 3D printed instruments. The idea that has been around for about 30 years or so is now being used in many creative industries, from crafting sculptures for Sweden's Ice Hotel to the latest Bond movie. The Spy's classic Aston Martin DB5 was replicated using one of the world's largest 3D printers, so the movie makers had a free hand in what happened to it, without the chance of scratching an expensive original. 3D designs are brought to life layer by layer. The thinner each layer is, the finer the detail. But with basic home printers starting at around £900 and that price falling quickly, many think it could be something we might all get involved in.
The biggest, most exciting thing that just happened is this technology that was really only available for the elite is now in the hands of anyone. Anybody can be an industrial designer. Anybody can be a mechanical engineer. Anyone can be an architect and make the prototypes and models and products at home.
Take this stove knob, for example. Today, if I wanted to replace this, I'd have to phone the manufacturer and get them to send me one. And that's presuming that it was still in production. Now, in future, with a 3D printer at home, I could simply download the blueprint and make my own. Or design one from scratch.
This is no ordinary guitar. It was made at a fraction of the cost and in less time than other models because it was printed in 3 dimensions. Making guitars are just one of the many uses of a 3D printer. It works by adding height to traditional 2D printing, giving it an alternative name, additive manufacturing. The concept of 3D printing has been around for a while, but it's only recently becoming commercial. As the printers become more affordable and people dream up new items to make, the potential is staggering.
There's millions of people with millions of ideas and they're all going to do something different. And it's incredible seeing the things that you never even thought of being made. And anybody who says they know where 3D printing is going is wrong, because there's so many thousands of ideas that no one's even had yet or have had and don't have a 3D printer yet.
It's perfect for creating prototypes to help with product development. Development that goes as far as creating a prosthetic limb. Amputee Wendy Melson lost the lower part of her leg in an accident. Designers were able to use a print of her healthy leg to base the new one on.
What that does is it recreates symmetry in the body. And there's something so sacred and meaningful about recreating body symmetry. And you really can't do that with traditional technology.
Then there are planes. Aerospace engineers have already designed, printed in multiple parts, put together and successfully launched model planes using a 3D printer. And it doesn't stop there. Airbus are considering making a passenger plane from a 3D printer by 2050, with transparent membranes like this. Seats that use passenger heat to power the plane, and it could all come from a 3D printer. That's if they can make a printer big enough. Designers predict it would need to be about 80 by 80 meters, the size of an aircraft hangar. It's a big dream, but one that may yet become a reality. Caroline Malone, Al Jazeera.